Welcome to the lecture series of Mathematical Modeling of Manufacturing Processes with subject code KME 073. I am Dr. Suman Gotwal, working as an assistant professor in the Department of Mechanical Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. So, in our last lecture, we started about the different type of engineering materials and their properties, and after that we discussed how we can evaluate the properties that are available in our manufactured products. In today's lecture, we will start mathematical modeling, and we will see what is mathematical modeling and what are the factors, what is the importance or requirement of mathematical modeling. So, these will be the outline during this lecture. First, we will see the introduction of mathematical modeling. After that, we are going to study about the statistical and data driven mathematical modeling approach. Then we will discuss the importance of the mathematical modeling. Then we will discuss about the different stages and then process of mathematical modeling, and at last we are going to discuss about the different factors. So, first, starting the mathematical modeling, we should know what is a model. So, model is basically used to represent something. When we want to represent something, and that something can be any system, okay, any activity, any problem, okay. So model will be used to represent something, okay. So we can say the models are the tools which are used to understand the behavior and the processes in the real world, okay, and to make the inference about the future. Now, the next question that arises is, what are we supposed to represent? So, the nature and behavior of the system or the activities which are involved in this system, or the various problems that are arising in a system, we can represent with the help of this model, okay. And if we suppose to represent all these natural systems, or like the nature or the behavior or the activities in the proper manner, then we will get a model which is known as the mathematical model, okay. So, in this we can represent all these systems, okay, all these issues we can represent, and when we will represent it in a proper manner, then we will say it is a mathematical model. Next is, now what are the ways to represent? So, there are different ways to represent something. So, we can draw it, okay, we can explain the things with the help of drawing, or we can explain with the help of some verbal arguments or a physical structure or the mathematical formulas. So, these are the ways with the help of which we can represent something, or we can explain our issues, okay. So, we can define the mathematical model as the process of representing the system with the help of mathematical formulas, and the structure obtained is known as the mathematical model. So, it is the process of representing the system, its behavior, its activities in a proper manner. And if we are using the mathematical formula to represent our system or our model, then the structure which will be obtained is known as the mathematical model, okay. Okay. Next, we come to the statistical and the data driven modeling approach, okay. Data driven, it means it is based on the data, okay. So, data driven modeling approach builds the relationship between the input and output data. So, In case of the data driven mathematical approaches, we will relate the input and output data, how they are affecting each other, what is the impact of these variables on each other, without worrying too much about the underlying processes. So, we will not focus much on the processes, we will focus on the relationship between the input and the output data. Okay, using the statistical or the machine learning techniques, and to relate these input and output variables, we will use some techniques also. So, with the help of these techniques, we will establish the relationship. And what is statistics? It is the study and manipulation of the data, including the ways to gather, review, analyze and draw conclusion from the data. So, as its name indicates, that statistical and data driven modeling approach. Okay. First of all, we will gather the data, okay, and after that we will review that data and we will analyze that particular data, and after it we will conclude the we will draw the conclusion from the data, okay, to establish the relationship between the input and output variables. So, if we talk about the example of this data driven modeling approach, so a perfect example is the linear regression model. Okay. So, in the case of the linear regression model, what we do, a data driven model, it is an example of the data driven model. So, in this we basically built a relationship between dependent variable and a set of independent variable. So, in case of the regression model, there are two types of variables are available with us. One is the dependent variable and one are independent variable. So, we will establish the relationship between the dependent and independent variables here, and this regression model can then be used to understand the relationship between the variables. So, once we establish the relationship between different variables which are dependent and independent variable, we can understand or we can see the impact of these variables on each other, and in some cases can also be used to make the predictions. Okay, we can predict also. Second example of the data driven modeling approach is the language translator. Okay, in case of the language translator, basically these are built purely by a data driven approach. Clear? For example, the Google Translator. If we talk about the Google Translator, then the Google Translator does not know anything about any language. Okay, Google Translator does not know anything about any language. It is built using the deep neural network based on statistics and probabilities rather than grammar rule of the language. Okay. So, if we talk about the language translator or the Google Translator, these are also data driven modeling approach, and in these we will use these techniques. Okay, deep neural network will be used and these will be based on the statistics, means we will gather the data, review that data, analyze and then we will draw the conclusion from that data, and they are not based on the grammar rule of the language. Clear? So, these are the example of this data driven modeling approach. Now, we come to the what is the importance of a mathematical model. Okay. So, what is the need of mathematics to represent the system? So, what is the need? Need is to establish the relationship between the different attributes, variables or the factors. Since in analysis of the system, the mathematical model plays a vital role which other models like physical, chemical, linguistic, etc. cannot do. Okay. simulation on model rather than experiments on the actual system. So, with the help of the mathematical models, what we can do the simulation process. We can test our models, okay, which we have built, rather than experiments on the actual system. If we will perform the experiments on the actual system, then the energy, cost, time all will be wasted, and it will not be economically justified if the deviation will be present. Okay. So, we will first do the simulation on the models to check its performance. To understand the physical behavior of the system, if we want to understand the physical behavior of a system, or we want to understand the different activities which are involved in a system, then for that also we can use this mathematical modeling. Economic, it is an economic way of measurement. We can control the parameters also. How we will control the parameters? Because we are relating the parameters, so we can see what is the impact of these parameters on each other, and then if one parameter is affecting the other parameter in a negative way, then we can control it to predict the future nature which have not been seen so far. So, we can predict something also. For example, in case of the forecasting, okay, we are predicting the future activities. So, for this we basically we analyze the past data. So, we can use to predict. So, in engineering and technology, it provides the analytical basis for design and control in which predictions can be made without spending valuable resources of money and efforts. Okay. So, this is the importance of mathematical modeling. So, now we come to the stages of the mathematical model. So, we can say the mathematical modeling process have the 6 stages, okay, such as the understanding the problem, and then after the understanding the problem we will choose the variables, okay. Then after that we will make the assumptions which will simplify our model, and then we will solve the equations. After that we will interpret the solution and then validate our model, okay. And after validating the model, we will criticize or improve our model if any deviations are present in it. So, these are different stages of mathematical modeling. So, what are we doing? This is the real world problem. We are understanding our problem, okay. Then we are simplifying it and we are converting it into the working model, okay. After we have converted the real world problem into the working model, what we are going to represent? We are constructing the equations, we are choosing the variables, we are making the assumptions, okay. And what is the meaning of the mathematical model? We are relating the different variables with each other, okay. After that, translate and we come to the computational model. Computational model means after once we have established the relationship between the variables and we have represented our model in terms of the mathematical model, after that we will go for the computation with the help of different techniques, means we will solve the equations with the help of different techniques, okay. After the simulation will be done. Simulation, in this we will check the performance of our system and then we will get the outputs, and from the output we will or we can say we will say get the results or the output and we will draw the conclusions, okay. If our output is similar as the real world problem, then we will validate our model. Otherwise, what we will do? We will interpret the solution, okay, or we will improve our model. So, these are the different stages of the mathematical modeling. Okay. So, we can see what is the process of mathematical model. So steps are basically same here. We can see here this is our actual system. Okay, we will first we'll take our problem, what type of problem we want to solve. So we will take our actual system, and after that we will define the variables, parameters or measures which are involved in this system. Okay, define variables and parameters, and after defining the variables and parameters, what we will do, we will construct the equations to establish the relationship. After constructing the equations, we will check these equations, do equations satisfy the actual model. We will check our system, we will check our equations whether they are satisfying the actual system or not. If they are satisfying the actual system, then we will go for the computation, means we will solve our equations for the output. But if in case the equations are not satisfying our actual system, what we will do, we will again define the variables and the parameters. Okay, and after solving our model for the outputs, what we will do, we will check does it predict original system, क्या ये हमारे original system की जो output होनी चाहिए थी उसके similar output मिल रही है. If yes, then we will validate our mathematical model. Okay, if no, if we are not getting the output that are required, then we will again construct the equations. So this is the complete process of the mathematical modeling. Okay, now we come to the different factors. Okay, so different factors of mathematical model. After developing a mathematical model, there are some parameters on which it should be judged for the applicability. Okay, so there are some factors we have to check. So few of important parameters are, first one is the scope. Okay, scope में क्या check करेंगे? We will check our model whether the model is able to define the scope of the chosen real world problem, means actual system. Whether our mathematical model model is defining the scope of that actual system. We will check in this factor. Okay. After that we come to the next factor, which is the complexity. So complexity is basically, is the model too simple or it is too complex. Okay. So it should not be too simple and it should not be too complex. In terms of the parameters involved, are they sufficient enough to represent the actual nature? We have to select the different parameters and variables in case of the mathematical model. Then we will check whether our system is complex one or the simple one. And we have to keep in mind that it should not be too simple or too complex. Okay, and it should represent the actual system. The parameter which we have selected or the variables which we have selected should represent the actual system. Now we come to the computation. In case of the computation, we will see what is the computation cost of the model. Is it reliable? It should not be much costly, and we will see whether it is reliable or not. So we will check here the computation cost, because for the computation process we will use different software, we will use different techniques. So we have to check the cost of the computation here. Okay. Then we come to the accuracy. In case of the accuracy, we will check does the model produce accurate or close to accurate outputs. So here we will check the outputs, whether the outputs are similar to the outputs of the actual system or not. If the outputs are similar, then only in this case we will validate our mathematical model. Okay. Then we come to the stability. So stability is basically the state or the quality of being steady, means not changing. So whether our model is stable or not, we will check here. Okay. It should not happen that on changing one parameter only the complete mathematical model should change. Okay. So here we will check whether our model is stable or not. Then we will go for the consistency. So in this case, what is the consistency? Consistency is basically the quality of having the same standards, okay, or same opinions or the behavior, etc. Means it should give the same output. Okay. So does the model misbehave with the given perturbations? Okay. So it should maintain the standard, it should maintain its behavior. Okay. We will check here. Okay. These are the references, you can see here. So thank you very much. That is all about this lecture. So in today's lecture, we started mathematical modeling. We saw how we can represent our problem, our actual system into a mathematical model, how we can establish the relationship between the variables, input or output variables. After that, we saw the process of the mathematical model, or we can say the different stages of mathematical models, and then we discussed about the importance and the different factors of the mathematical model. In our next lecture, we are going to discuss more about the mathematical model. So thank you so much.